going to do is draw a picture of the inside of the oyster. And we have some things to help you do that. This one is labeled, and these have spelling names and everything, and I'll help you with that. But the first thing I want you to do is just look at it and draw a picture of what you see.
What do you think the oysters are doing in there? Yeah. Can you see this one? Is this one open? Yeah.
I know. One time we were cooking mussels and my mom got limerents and we saw them go. Yeah, it was really cool. Don't say that in front of the clams. Sorry, clams.
So in here you'll be able to see them more when you dissect an oyster.
Whoa. Whoa.
That's oyster excitement right there.
They're not big fingers. On this black edge you can just kind of see some little things sticking out. You do see them? Good. Those are the tentacles. The watershed station. You can if you want to.
You want to go try to find it? So let me give you perspective. Yep, there's your muscle.
Yeah.
Piece right there.
You did more in first.
Okay, well let's take a look. So this is U Street all the way down by almost the cemetery where the stoplight is. So you're down there?
I live on the very top.
You live by like
I got on I can't even. I think about 50 years old.
I'll tell you when we're done.
Maybe about.
There you go. So they put on a couple layers every year. 2, maybe 3 right here. 4, 5, 6, 7. This one's 7 years old. These ones are probably a couple months old. Yeah, it hasn't really put on its first full one. Yep, it's a little baby oyster.
It looks like a hookworm.
How are you girls doing with those few questions? So, what organ does an oyster use to breathe? Any guesses? What do fish have?
I can use this.
Oysters have the same thing. Yeah, you're going to see them over there.
Storm drains or gardens. So things like rain gardens are very great.
There's a big body of oil.
Yeah, so we got a little lake going on now. Sure. Oh, look at all the stuff that they're.
What is getting released from driving cars and factories? CO2. Yeah, so we're going to talk about carbon dioxide a little bit more here today because this whole lab is about ocean acidification.
Experiments about ocean acidification and pH. And if you don't know what those are now, you'll know by the end of this class.
So we're going to do an experiment where we take the CO2 from our breath and we're going to put it into one of these cups.
Whoa.
And we're actually going to be able to see a change. And to understand what that change is, Julie's going to talk a little bit about the pH scale.
You're going to be able to dip it in one of your household solutions to find out if it's acidic, neutral, or basic.
And you are going to start blowing your breath into it. Yeah.
All the way till it touches the bottom?
Yeah, till it touches the bottom. You're going to be blowing bubbles into the water.
Yay!
We're going to answer the last couple questions and then we're going to start.
Because they haven't finished yet.
They might not finish, but we're going to answer these questions and then we're going to do.
So when you do observe a difference, you can look at page number 5 in your books and start answering some of the questions.
If you found a change, let's record the change that we've seen.
So what do you think happens? Have a little more.
Basically not.
No? Okay.
All I can see is my guard.
A tiny bit? This tiny bit what? Okay. Darker?
I'll do mine, okay? And look at how fast the change is. Look at that. Okay. I'll put
put it here. Wow, that was the most changeless.
What made them different?
This color is darker.
Yeah, so the color changed, right?
Let it sit for a minute.
Can I have one, please?
You may have one.
Dividends. It's very acidic. How else you'll find that? What did you guys say? Acidic. I'd say acidic. No, actually it's not. Yeah, it's more neutral. It's more neutral.
So after a few minutes of blowing, you're going to put your cups side by side onto this white paper, and you might be able to see a difference, okay? So you can start writing in here the color of your cup number 1 and color of your cup number 2. Which is a difference, isn't there? Yeah. Yeah, which is...
Go ahead and lay it down here. Just lay it down. Don't worry about where. We'll move it around in a second.
Look at the scale, see if you can see the change.
It turned to neutral. It's coming from my cup.
And what does that mean? It turned pink according to the scale.
It's the same.
What was happening?
Look at mine.
Is it dark? So what does that mean?
It's more basic.
So you can write more basic. And they're going to turn white.
Oh, yep, basic.
And the colors mean...
So, what are we on? What do we just do? That's acid. Because I don't know. Yeah, let's do acid. Is that milk?
No.
1,000, 2,000. Oh, it's basic.
Lay it down.
What? Basic?
You didn't expect that?
No, I thought it was it has a really thick sheet. The one in water, it's like kind of falling apart. Plants grow really slowly. I grow really quickly. Seriously, I do.
So where is this carbon coming from? We have 3 main categories of where carbon comes from, carbon dioxide.
Our breath, cars, and...
Yeah, it changed that water to be more acidic. Was it the temperature that changed the color, or was it something that was in our breath?
It was CO2.
CO2 that came from our breath, and it changed the color. And what did that color change mean? Anybody know what that color change meant?
It was more acidic.
Yes. Do you remember what the shell in vinegar felt like?
Soft and moist, and it could be broken easily.
Mm-hmm.
Yeah.
Yeah. So this is happening right now with ocean acidification. So this field trip that you get to go on to, we are actually going to be collecting scientific data which will actually be published online. And each group is going to get a bag of shells, and you are going to sort these shells as your group sees fit.
Okay, then we'll put stripes and wings on my belly. So this will be not smooth and not smooth. Smooth.
So you've started noticing some different characteristics on these shells. And this is actually kind of what our field trip is about.
I saw it on a restaurant.
So school is right about where this cluster of thumbtacks is. And Chucknut Bay is right here. We compared it to data that's already collected. What might we find out?
Ocean acidification.
We might see if ocean acidification is taking place, which maybe would mean a decrease in clams. So each group is going to get a set of sheets, and you're going to spread the sheets out on your table, and you're going to set the clams on top of the sheets so they match up. Okay?
Oh, horse clam. I guess now we're all switching clams. I'll do it.
Tap the shell.
Like this?
Which ones feel thick and which ones feel thin?
This one feels really thick.
And butter clams do not have a bend. You see the bend right there? So if it has a bend, it's a macoma. And then, which type of clam is the least plentiful or abundant? Which one do you have the fewest of?
That one that has one. Horse clam.
Horse clam, you got it.
I'd rather have nature call me. I'm gonna walk all the way. Well, where's the water? The water's right there, people.
But you guys back at school, you already learned a little bit about how to tell apart the clams, right?
Yeah.
Okay. It's hard to dig a hole with this big with this like hose here, my loop. So like, that's where I need to dig. Okay. It's hard to see here, but when it's wet, it's a lot easier to see. So I've made myself a mark with that. All right, so now I'm gonna start digging. Okay, and I'm gonna dig exactly inside my hole.
How about the ones with the bigger one? Yeah, because that one's a little bit. Oh, baby's climbing out! Back, baby, back. Your nap time's not over. Mama just got here. There we go. To 1.6. What? Tell us on the... I don't know.
Okay, Zoe. Now put it on the tarp. There. Oh, shoot.
What?
It's okay. All right. So if you do see clams, you guys, let's start setting them off to the side.
I just got caught!
Stop moving.
No!
Okay. Here, Savannah, hold this.
Me.
So everybody come on, we got to sort this as we dig through, and you're looking for any size clam.
Plus, you have to make this thing dirty.
So you can just sort of smear it, squish it. Even little baby ones too, so they're hard to spot sometimes.
Yeah, but the mud is going to be
Nope, that's a shell.
I'm jumping!
How are you guys doing? How are you guys doing?
Well, we're just starting to sort out. Spot down, and you guys, the other mud goes in back in the hole after we sort through for.
I thought it was really fun, like doing all the like research about the clams, like learning what types of clams there were, and it was really fun doing the clam survey.
So why do marine biologists go out and count clams? What's going on?
Because the first year they did it, they wanted to see how much clams there were. Then the next year they wanted to see how much less, if there were less clams or more clams.
4 years later.
4 years.
Oysters are dying because we're polluting. Well, we're making the ocean acidic, so it softens their shell.
And also shellfish might become extinct in some places or endangered.
If that happens, then the food chain would probably collapse.
So I'd like to know which of those activities you thought was the most interesting, and if you could tell me why.
I forget what it's called, but cabbage water, and cabbage juice, and then we tried to make it turn colors, and I thought that was interesting because I didn't know that anything could turn colors if you blew into it for a while. And they gave us cups of purple cabbage juice, and we would blow into it, and because we blow out CO2.
What's CO2?
CO2 is the abbreviation for carbon dioxide.
All right.
The carbon, if you blow in lots of carbon dioxide, it'll change lighter. CO2 can ruin our seawater, and it can kill plants, food, and everything.
Why should I be worried about clams?
Because the more they get smaller, more of the sea could actually die inside. If they get bacteria in them, they get toxic and the food chain will just collapse.
I want the Salish Sea to live and grow, not just die away like some garbage dump or something like that.